So for the most part, that first video gave you guys all the real information. I will bring back some of those pictures while we go through these example problems, and hopefully that'll make sense. So I'm just going to look at 36 and 38 and then move on through a couple other problems for you. Let's get to let's get to 54 or 64. I'll have to decide once we get closer. If we can get that far in this video, then I think we're doing pretty good. So this is number 36. And remember, when we are using inverse trig functions, we're actually finding an angle. Okay, and so this is all, should be very familiar looking to you. These are right triangles. Sohcahtoa is still the thing that you want to remember. I guess someone told me that you guys don't know Sohcahtoa. I don't know. So, make sure you guys actually speak up when I think you know something. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Okay, so that's where all that comes from. Okay, so that's still going to be what we're thinking about here. And so you're being asked to use inverse trig functions to write theta as a function of f. So then a function of x. So then theta, right, we have a hypotenuse and we have an adjacent. So that should be thinking of cosine. And so then we're going to say theta equals arc cosine of 4 over x, adjacent over hypotenuse. So 38. Okay, and just like anything else in algebra, don't get worried about expressions as part of what we're working with. It's still the same thing, right? We have opposite over adjacent, and so in this case we're saying that theta, again, opposite over adjacent, think of a tangent. So theta is equal to arctangent of x plus 1 over 10. So I'm going to skip ahead to the 45 to 54 section. 39 to 44, I answered those questions in the first video. So if you're not sure what you're looking at there, go check that out again. But, tangent and arctangent are opposites, so that shouldn't really be a horrible thing. But I'm jumping down to this next section because we are using, not inverse properties here. And so these are a little bit more tricky. I put on the screen, the unit circle again and the definitions of inverse trig functions. So we are looking, paying attention to our range, because that's going to be important when we're doing this. Then the directions say find the exact value of the expression, and they give you a hint of making a sketch of a right triangle. So again, all this stuff is very related to the right triangle things. But what we're going to do here is we're going to make a little substitution in here. And I'm going to say that, hopefully I don't run out of room here, we'll do it over here. So I'm going to say that u is equal to arc sine of 4 over 5. And I guess the way I look at this is we're going to use these inverse properties, and those are that sine and arc sine are inverse properties. And I guess kind of the way I'm going to look at it is we can take the sine of both sides of this new equation that we came up with. And so then if we do that, we would say sine of u equals sine of arc sine of 4 over 5. And then, you know, if you remember from the other video, again, these are inverse operations in a way. And so they kind of cancel themselves out, and we're left with sine of u equals 4 over 5. Okay, and so now this is where the right triangle can come into play. And, you know, just to remember here, right, the signs are between negative pi over 2 and pi over 2. So negative pi over 2 to pi over 2. So we better be in this part of the unit circle in our thoughts. And we have positives in this case, and if you look forward, some of these are going to be negatives. So we're positives in this case, so we got to be up here in the first quadrant. Okay, so I'm going to draw my triangle to represent that idea. So then we're looking at this. And I'm definitely going to run out of room. So then we have this u, and sine, again, Sohcahtoa, opposite over hypotenuse. Okay, so we have the secant now. And so really what we did over here, we made this substitution, and so now we can jump down and say, okay, so really what we're doing is, what is the secant of u? Okay, and I'm probably going to have to erase some stuff. Oh, I can move down. Never mind. So I'm going to have to move up and around for you guys. But so then, okay, so now you got to remember what secant is. Well, secant is really, you know, this is the same as 1 over cosine of u. And so what that means is if we can find the cosine of u, we can just take its reciprocal and go from there. Now, and that would be our answer. Now, the problem is, of course, with our right triangle, we only have two sides here, and cosine is talking about adjacent over hypotenuse, and so we do have to find this this side. Hopefully, most of you right now know about 3, 4, 5 triangles. Otherwise, that's not a big deal, because what we're going to do is say 5 squared equals, we'll call this one x, equals x squared plus 4 squared. And so that's 25 equals x squared plus 16. Subtract the 16 over, 9 equals x squared. So x equals plus or minus 3. And so that means our x is 3. Okay, so 3, 4, 5 triangles are a big deal. You guys should know them. Otherwise, you're going to have to use Pythagorean Theorem. And, you know, if it's not a real obvious one like that, then you're going to have to use Pythagorean Theorem. So what we're doing then is saying, okay, so then if I was looking for cosine of u, that would be 3 over 5. And so I'm really looking for secant of u, which again, what we said before is that's 1 over cosine of u. And so then that's going to be 5 over 3, and that's your answer there. Okay, so we're going to look at another one. And, you know, I wanted to do this one just because of the negative sign there. You know, that's going to come into play in the way we answer. And, you know, again, we need to check out where our range is going to be here so that we're picking the right quadrants to play around with. The negative is going to show us something here in a second. So tangents, arctangents have that same domain as the arc sine, so we're over here. But now we're talking about something negative, so now we have to be down in the fourth quadrant. Okay, so I'm going to draw my triangle a little bit differently when I get there. But first I'm going to just make this little substitution again. I'm going to say, well, let's say that u is the same as arctangent of negative 5 over 12. Okay, and so then we're going to use the inverse properties of tangent and arctangent. And what we're going to say is I'm going to take the tangent of the left side, so that's going to be tangent of u, and that's going to be the same as the tangent of arctangent of negative 5 over 12. And so then tangent and arctangent cancel themselves out since they are inverses. And so now we have the tangent of u equaling negative 5 over 12. So I'm going to fit in this right triangle over here. But again, now we're down in the fourth quadrant, so our triangle will look like this instead. Okay, and this is our u. And so then remember that tangent is opposite over adjacent. So then we're going to say, since we're down in the fourth quadrant, that makes this negative 5 and this 12. Okay, and we're just writing it that way so that we have our signs correct for when we take the cosecant of all of this. We do need to find the third side again because we're being asked about cosecant of this. And remember, cosecant is inverse, or not inverse, sorry, the reciprocal of sine. Okay, so sine being opposite over adjacent, we do need to find the, I'm sorry, I missaid that. Sine being opposite over hypotenuse, we do need to find the hypotenuse. And this one isn't quite as easy, but we're going to just work it out using Pythagorean Theorem. And we'll call this c. So then we have c squared equals 12 squared plus negative 5 squared. And so then c squared equals 144 plus 25. C squared equals 169. And so then c is plus or minus 13. And then, we talked about at one point the hypotenuse is always going to be positive on these. So then we're going to say 13. Okay, and so now we're almost done with this. We're going to come back over here, and we're going to say what we really have from this top, after all of this substitution work, we're going to say, well, we're really finding the cosecant now of u, because we made this substitution here. Okay. And so that means in our mind, we know that this is true. And so, or at least the way I do it anyway, the way I think about it is, okay, so sine, if I was looking for sine of u, that would be opposite over hypotenuse. So that would be negative 5 over 13. But really what I'm looking for here is cosecant, which is 1 over sine of u. So then we're saying that it's negative 13 over 5. Okay, so I'm jumping down to the next section, and it's really the same thing. And hopefully you guys are feeling more comfortable with variables and numbers. I mean, they're interchangeable. They all mean the same thing. The only reason that 55 to 64 is not the same as 45 to 54 is that we have a bunch of variables, but we do these problems exactly the same way. So I just picked 58. I think it's a good one to do. So, again, the steps are exactly the same. These are not inverses of each other, secant and arctan. So we want to make this little substitution again. So we're going to say, okay, well, let's say that u, and again, remember that is, when we're talking about arctan, we are talking about an angle here. So u is going to be an angle again. So we're going to say that u is arctan of 3x now. Again, don't let that freak you out. And then that means, to do it in slightly different order here, so then we're really going to find secant of u. Okay? But again, I'm going to go through. We got to set up a right triangle here. And so back over to the red, I want to take the inverse of arctangent on both sides. So that's going to be the tangent of u equals the tangent of arctangent of 3x. And then since they are inverses, we're able to say the tangent of u is now 3x. And now I guess it is a little different in the way that it looks, in that we don't have a fraction anymore, but everything still applies. Everything that we've ever talked about in math is still true right now. And that means that any expression can always be over 1. So we can really think of this, if you would, or what we're going to think of this as, is really 3x over 1. And so then that falls into, right, the top is adjacent, and the top is opposite, and the bottom is adjacent. So we're going to come down here and draw a right triangle. And I guess in a way, these are probably a little bit easier because you don't have to worry about your signs anymore. So sign as in positive or negative. So there's our u again. We are looking for, again, we're doing opposite, which is 3x, opposite of u, over adjacent. We are going to talk about secant. Again, that's 1 over cosine of u. So we do need the hypotenuse here. So let's go through with Pythagorean Theorem and find the hypotenuse. Again, we'll call that c. So then c squared equals 3x squared plus 1 squared. So then c squared equals 9x squared plus 1. So then c equals plus or minus the square root of 9x squared plus 1. Again, we talked about our hypotenuse always being positive, so then we're going to say that c is the same as the square root of 9x squared plus 1. So now we're coming back and remembering that we're finding secant of u, and secant is the same as 1 over cosine of u. And so again, I like to go over here and kind of just do this. Cosine of u would be the same as adjacent over hypotenuse. And so then we're saying that secant of u is the same as the square root of 9x squared plus 1, because we just flipped that over on its head. Okay, so hopefully all that makes you feel pretty good. So, I'm looking ahead to these other parts. Again, all this stuff is due Monday. I think if you do that much, that's good. But, as I'm looking ahead, I don't really know if another video makes sense. I'm looking at 65 and 66. They're just asking you to use your graphing calculator. Again, if you don't have one, Desmos, Calculator X. And you're going to graph both and see they're equal. And then they're asking you to explain why they are equal. Well, basically, this problem that we just did, 58, is kind of what is going on there. Okay, so play around with that idea, graph them, see, okay, yeah, they're the same. And they do say name some asymptotes, and if you're looking at 65 and 66, they have variables in the denominator, so you should know definitely that they got some asymptotes. All those rules are the same. And, if you're looking at the F part of 65 and 66, we got tangents going on and arctangents going on, so definitely there's some some of those. 67 through 70. Again, if you understand 58 here, that's basically all you're doing. Okay, so when I did these, I made myself a little right triangle. Kind of did a substitution of u just like we did before. Maybe you guys aren't sure on that, but I can post number 70 maybe to Google Hangout if that's what you guys want to do. So I think all that should be pretty good. If you would like something explanation on 71 to 78, then I can also look at that. But again, I'm not super concerned if you guys can just rip off these graphs right off the top of your head. If you have the book or you need the videos or whatever, go ahead and relook at the standard graphs, and then everything still applies the same way. These are just functions. So, like 71, it's 2 times the arc cosine of x. And, 2 is just going to be stretching us in some way, okay? Because the x values going in are all going to be the same, but then they get multiplied by 2 for the y value. 73, we're just shifting that a little bit, and so on, okay? So try to figure those out, graph them, see how close you were, see if you understand it. If you need some more explanation on that, please ask. And then, just like all the other sections, those are kind of the meat, and now we're applying it through the rest of the way. So please ask. If I don't hear back from anyone, then I'm not going to do another video on this section because it's kind of all just doing the same thing over and over again. But if you guys would like another video over something, or if you are interested in a specific problem, remember, I'm doing 9 to 10 just for you guys. Go ahead, post something there. Tell me in the message on Google Hangout if you just want a picture and an explanation video, or just a picture, or whatever you guys are looking for, okay? So please let me know how it is all going. And like I said, unless I hear something specifically, this will be the last video on this. But please ask.